Welcome to the Mold section of the CADmeister 2025 version upgrade. In this release, Mold was developed to aim to improve various functions of each process in resin mold design to achieve greater efficiency. These enhancements include improved mold modeling functions, mold concept design functions, and better utilization of 3D data. The first topic is improve usability for trim and divide commands. We would like to introduce the improvements to the trim and divide command. Trim and divide is a command that is frequently used in mold design, for example, when modeling slide tips. In CADmeister 2024, it was necessary to create surfaces or infinite planes in order to perform trim and divide. As a result, unnecessary surfaces remained in the model, and additional work was required to delete them afterward. In CADmeister 2025, trim and divide can be executed simply by specifying a cutting plane, which is automatically treated as an infinite plane. This eliminates the need to create or delete unnecessary surfaces and makes the workflow smoother. In addition, offset and reverse operations can now be performed directly within the trim and divide command. It is also possible to perform trim and divide on multiple composite surfaces at the same time. Furthermore, data that contains a mix of composite surfaces and solids is also supported. As a result, the trim and divide operation has become simpler and more efficient. The second topic is added ejector pin type, sleeve, free color, and rectangular with R. In this section, we will demonstrate how to call up the newly added ejector pins. A sleeve pin is placed on a boss shape with a hole. Therefore, please check the boss and hole dimensions in advance. You can find the Place Ejector Pin command here. Select the sleeve type from the ejector pin type options. Specify the required dimensions. And place the pin. Since the free flange has already been set in advance, only the sleeve pin will be placed this time. At the end, the complete pin configuration, including the free flange, will be verified. Next, we introduce the free flange pin, which is now available as an option. When the free color is selected, the registered catalogs are filtered accordingly. Select the nominal dimensions and place the pin. Free flange pins are components that protrude with a slight delay. You can adjust the protrusion timing as needed by adjusting the stroke under collar value. Lastly, we introduce E-pin placement with corner R. When placing a rectangle pin, a radius may be more convenient due to machining considerations. With this improvement, catalogs for 2 corners R and 4 corners R types can now be selected. Specify the required dimensions This part is adjacent to the split point of the nest, so 2 corners R are placed.
When zoomed in, you can see that an R has been added to the corners. Next, place a rectangle pin at the split point of the nest, where it is divided in two in the middle of the rib. For this location, the four corners R-type is selected. Similarly, it can be confirmed that R has been applied to all four corners. This concludes our overview of the newly added ejector pin types in the ejector pin placement function. The third topic is enhanced usability of change placement. Introduction to improvements made to the change placement command. First, from Mold Express, import the joint for connecting the cooling water pipe. In this example, select the L-type joint. Next, assemble and position the imported joint as shown. By default, the joint is placed at the origin of the main coordinate system. Here, activate Change Placement command in the part Assemble to adjust its position. Drag the handle to move and rotate the joint to a clear and convenient view. Next, switch to the newly added Adjust Position method. First, to connect to the cooling pipe, apply a concentric constraint between the joint and the water pipe. Next, apply a distance constraint to position the joint slightly inserted into the mold. Previously, when aligning components, it was necessary to define constraints through Define Assemble Constraint or History Placement. With this improvement, placements such as face-to-face alignment can now be performed without defining constraints. As a result, the Adjust Position method enables smoother placement operation without adding assembly constraints. Next, to install a slide at the location where the insert claw is present, adjust the slide unit. Activate Change Placement command in the part Assemble. As before, use the Adjust Position method to refine the placement. In this case, the adjustment is performed using only a distance constraint, maintaining a fixed distance between the surfaces. Finally, complete the process by fine-tuning the position using handle controls. The newly added Adjust Position method allows you to achieve smoother and flexible positioning in your design workflow. The last topic is Material Size Attribute Setting, automatically assigning material sizes to machining parts in bulk. In this section, we will introduce the Material Size Attribute Setting command. This command allows you to measure the dimensions of a solid model and automatically store those values as part attributes. Here, you can see examples of insert parts and ejector pins used in mold components.
We will use the Set and Display Production Requirement palette in Mold Creator to view and manage information items.
Some parts, such as ejector pins and straight ejector pins, already have predefined attributes. Next, we will assign part attributes to an insert that does not yet have any attributes set. Using Import Mold Requirement command, you can import attribute data from an external file. The file contains registered information such as part name, part code, material, and machining category. When you select a part, you can see that the imported attributes are displayed in the table on the right. The imported attributes can also be copied to other parts of the same type. This allows you to reuse the attributes as needed without importing it again each time. In this example, only the part name of the copied part is modified. Next, we will set the material size. Using Material Size Setting command, material dimensions are assigned to the selected inserts. In this example, two inserts, Nesting 1 and Nesting 2, are processed at the same time. You can see that different X, Y, and Z dimensions have been imported for each insert. Finally, we will set the size for the ejector pins in a batch operation. At this stage, the dimension names in the part attributes have not yet been defined. Three types of pins are selected, and their dimensions are automatically calculated using Container Cylinder command. The system extracts the diameter and length from the geometry of each pin type, including ejector pins, sleeve ejector pins, and straight ejector pins. This concludes our introduction to the Material Size Setting command. We hope this feature helps improve your workflow in your daily operations.
Thank you for watching. Please like, subscribe, and share.